So tomorrow quiz is this thing that's in front of you that's titled 3.5b. So 3.5b, let's fill in everything from 13 down, because that's the things that you learned about from the reading. So I believe these are the same 5 questions that you got today anyway. So what was the famous problem that was in the reading?
Like the 7 bridges.
Yeah, so pretty much today, if you have anything about bridges, I would take it. For tomorrow and for test, let's go with the official title of 7 Bridges of, and then does anybody have the town?
Königsberg.
Königsberg, which is K-O-N, with the fancy 2 dots on the end. Oh, I don't even know what that's called, but in America it looks like Königsberg, but they're saying you pronounce this Königsberg, and I'll take their word for it. If you don't spell that perfectly, I'll live without it. That's not absolutely crucial, but you've got to get close on that. So, anything today, you said bridges, that's fine. But we'll go 7 bridges of Königsberg. Then, who was the guy?
Leonardo.
Yeah, anybody spell his last name?
It's like E-U-L-E-R.
E-U-L-E-R, which is pronounced Euler, which we're dealing with some German pronunciations, but E-U-L-E-R, he is Euler. So people in the town are trying to figure this out. There's these 7 bridges. You're trying to cross the bridges all once and end up right back where you started. And people had kind of started to come to the conclusion, we don't think you could do it. We don't think this is possible. And then after people had done this for quite a while, Euler stepped in and said, what? What was his solution?
It's impossible.
It is indeed impossible. You guys are right. You cannot do this walk the way people are trying to do this walk. It can't be done. And then he explained why. And once he explained why, I have to think some of the people had the reaction that I did, which is, why couldn't people figure this out? It wasn't really like, wow, Euler, you are so smart. Why couldn't they cross these 7 bridges and end up back where they started? Because the number wasn't even. So every time you would do an odd, if you started off on the island, every odd amount of bridges you cross takes you off the island. Or if you started off the island, every odd number of crossings puts you on the island. So there's no way you could do all 7 once and end up back where you started, because the odd number of it just took you to the opposite place. So that wasn't like super earth-shattering. But in doing that, and in doing some of the other stuff he did, he invented a branch of mathematics. And that would probably be the least likely question you hit from the reading, because they didn't like super stress this word. Anybody have the word of the branch of math he invented?
It's like typology.
It's something like that. Topology. T-O-P-O-L-O-G-Y. Topology. If you read carefully, you should have picked up on the disability he had, which wasn't really like super maybe important to the biography, but that's something that I think would stand out when you read about somebody who's a famous mathematician who was blind. That makes your work as a mathematician a little more impressive. You're taking geometry, you're doing however you're doing. Imagine if you were doing geometry and you were blind. That would increase the level of difficulty in you doing your math a great deal. It makes him a fair amount, I think, more impressive that he was able to do things. But that was what that section was about. The homework tonight is pretty much unrelated to anything else in the year. We could pretty much do this homework the first day of school, the last day of school, or any day in between. It has not one thing to do with points, lines, or planes. It's a one-day timeout to basically do some topology problems. Penn State, majoring in math, 1 semester, I took 15 weeks of topology problem class. I thought it was sort of fun. It basically amounted to a lot of little like math games and stuff. A lot of weird little questions, some of which were annoying, some of which were fun, some of which were anywhere in between. But tonight you're going to get a feel for a variety of topology problems. So let's take a look at page 69. Page 69 is the homework tonight. It's going to take us from numbers from 1 to 9. And honestly, this is a homework, you could probably do this homework in 12th grade, you could probably do this homework in like 4th grade. It's just like, it's unrelated to anything you ever have or will see again. Just a taste of what does topology look like. If you like this, go to college someday. If you go to college and they say you have to take a math class, you could ask them, do you offer a class in topology? And if you were a fan of this, then take that class. You might enjoy 15 weeks of like playing these weird little math games. Before we do that, does anybody on this sheet, on the top 12, I didn't do any answers to top 12. We have done those other days, but I'll do it again. Does anybody on the top 12 need an answer or 2 or 12?
This is for 13 on the bottom.
Okay, 13,
I mean 15.
15,
Yeah.
was that you couldn't do the walk. So after you read that, talk back to the extra credit paper I gave you. I gave you a newspaper article about people in Pittsburgh crossing bridges. That's like a twist on this. It was like a combination of fitness, nerdy people that decided to like do a thing in Pittsburgh. Pittsburgh has a ton of bridges, I'm sure you are aware. So some Pittsburgh people who were into math but also into fitness organized some sort of giant walk through Pittsburgh where they crossed 1 million bridges and tried to end up back where they started or some such thing. I forget the details of the article. But read that, I'll give you a couple points. If you're turning in the extra credit stuff tomorrow's midterm, so I could count it on midterm. If you do it later, I'll still give you your points, but it's just, I can't get it factored into your midterm grade. But that's what the article is about. It's a bridge-related thing. Question, top 12 vocab, anything? Yeah.
What was 10?
10 is if for any 2 points, P and Q, that are in the set, the entire segment PQ is also in the set. Want to replay that? As long. For any 2 points, P and Q in the set, the entire segment PQ is also in the set. We need the phrase in the set there twice. The points are in the set, and then that segment is in the set, everybody's in the set. And if those words don't make sense, I could do an explanation again about what do those words mean, if you want meaning to those words.
Isn't that just the flatline postulate?
No, flat plane postulate is 2 points of a line in a plane. The line has to be in the same plane. That's only for lines. Convex is basically, they're trying to give you a definition which boils down to things can't have holes in them. This is a sort of a simpler way to say it, but they got very like precise because definitions are supposed to. But 11 is trying to describe to, or the convex definition is trying to describe to you things shouldn't be hollow inside, whereas the flat plane postulate is trying to say basically planes are flat. It's a little different. Anybody, things you want me to tell you an answer, or I gave you an answer but you don't understand what the words mean and I could try to explain what the words mean again? Anything on the vocab? Okay, so let's look through 69 just so you understand what the games are that they're playing. So for page 69, problem 1, it says, in this problem you win. The goal is cross each segment of the figure exactly once without ever lifting your pencil from the paper. They want you to copy the figures and then see if you can discover which of these you can win. And then they ask you to consider, is there any way to make up figures that cause you to lose? Because there's reasons why they couldn't walk the bridges. There's reasons why in this picture, this problem number 1, some of it works, some of it doesn't. So here's what they're asking you to do on this first one is, you have 4 places you could start. 1, 2, 3, or outside the figure 4. Somebody tell me, pick a random number where you want me to start my attempt. 2. So I'm going to start at 2, and I'm going to draw like a squiggle without ever lifting my chalk, and I'm going to try to touch 1, 2, 3, 4, 5, 6 segments in this picture. I'm going to try to touch every segment once. So do you want me to go right, left, or down?
Left or down?
I'll go left. Now I'm gonna either go more left or down.
Down.
Down. Now I could try to cross here or here. Do you want me to go right or down?
Right.
Right. Now the only place I can go without crossing something I already crossed is
Up.
out. Then I could re-enter somewhere. I could either re-enter zone
1,
1 or
3.
zone 3. Who do you want me to re-enter?
3.
I could re-enter 3. And I lost because I can't get out of here because I already crossed everybody and I never touched that. Does that mean every attempt would be a loss?
No.
No. That means I lost by starting in here and doing what I did. You know, maybe I should try to start outside and go in and down and here and out and back in. I lost, you know, you try a few. Some of the shapes lose, some of the shapes win. Should you try once and decide it's a loser? No. Try a couple ways. You know, start a couple different places, do a couple different strategies, but some of them do lose and some of them do win. But that's the game you're trying to play, is weave your way in and out, and there's a reason why the losers lose, there's a reason why the winners win, just like there were reasons they couldn't cross the bridges. But that's what you're trying to do on problem 1. Question about 1, what the goal is? Then question 2, 3, 4 all go together. What you're trying to do is retrace the figures without lifting your pencil. So if I give you something like this, can you retrace this without lifting your pencil? Not by going like this, but can you draw that without lifting your pencil? Like when I went like this, I had to lift my pencil to go again. Can we do it without the lift?
Yes.
Yes. 1, 2, 3, 4. Where should I start?
2.
2. Okay, so one way to do it is go from 2 to
3.
3
To 4.
to 4
To 1.
to 1
To
to
2.
2
To 4.
diagonal. Is that the only way we could have done it?
No.
No. But all of the ways that work have something in common. Can you give me another way that I can do that?
Start at 4.
Okay, start at 4
Go to 1,
to 1
2,
to 2
3,
to 3
4.
4
To 2.
to diagonal. There's something in common with both of those, but what you're trying to do is figure out, can you retrace it, yes or no? If you can figure out the reason why, all the better. It's a little bit back to the Egyptians versus the Greeks kind of thing. Like, the people that lived in town were like the Egyptians. They sort of noticed it, but then Euler was like the Greek. He figured out why. So, here, we don't feel like we can do it, we're a little bit Egyptian. If we can figure out why, we're a little bit more like the Greeks. If I go like this,
Nope.
do you know if you can do it? He thinks no. That's one of the questions. I won't tell you. But number 2, the middle box, is redrawing that. But 2, 3, 4, you're trying to retrace without lifting. And once you get to 4, they give you a hint as to how you can start to realize what the trick is to these. 2, 3, 4, question about your game? 5, they lie to you here. This is absolutely not called a Möbius strip. This is called a Mobius strip. That is an absolute lie that it's a Möbius strip. No, not true. It says you may have seen this, and you probably have. Does anybody know where you may have seen a Mobius strip?
And game.
And game. It says a Mobius strip is a piece of paper having only one side and one edge. It's fairly easy to make one. Cut a fairly long strip of paper, which your teacher already did for you, or use adding machine tape. You can tell the book is old at that moment. They ask you to give the tape a half twist as illustrated below. So here's what we're trying to do. Some of you guys in your lifetime might have made yourself like paper chains. Like you would paper staple this together as a link, and then you could make another link and another link. I don't know if you've ever built a paper chain that way. That's not what they're asking you to do exactly, but something similar. If you did it this way, if I took my pencil and I traced around the outside, I would never touch the inside. And if I tried to trace around the inside, I would never touch the outside. What they're asking you to do, and you can do this at home, take your paper, do a turnover. Not like a full 360 rotation where it's like tied into a knot, but you want to take your paper and do a half turn. Zoop. And grab some tape. And I would suggest taping the inside, and I would suggest taping the outside. And now an interesting thing will happen. So one thing they'll ask you to do here is, they say if you took a pencil and started to draw down the center of this strip, it isn't going to do what the paper chain would have done, where we had an inside and we had an outside and the two never crossed. If I keep rotating through here, through here, through here, look where I come to, I'm back to where I started. There isn't an inside and an outside, there's one side. Like this is a one-sided piece of paper now. There isn't a front and a back. There's just a one-sided crazy piece of paper. Then they ask you to do this. They ask you to cut it in half. So the way I would cut this in half is gently, not quite fold it, but get it closed up at an end. Do a little snip. And then I just follow the line I made. What do you think's going to happen? What do you say?
It's gonna be two.
I'm going to have two. Liar. Okay. So then they say, that was fun and weird. Let's do it again. So last time we were expecting two, right? You thought it would fall apart. Did it? Now they say, try it again. So what are you expecting this time?
It's gonna be one.
One, like super long one, because that's what happened last time. We had one like crazy long one, so we're expecting a crazy long one. And lo and behold, lies. There's two. but they're like bound together. They're like, they did make that chain, that like link chainy kind of thing. Like those aren't, I can't make them fall apart. Like how did that happen? That was crazy. Then they want you to go again. And I'm not going to do that, okay? So take it home, play with it. But the Mobius strip is a little bit like wild. I have a couple things in my cabinet I can show you tomorrow that are way wilder than this, but we'll save the cabinet surprises for tomorrow. But, play the Mobius strip. You want to get narrower than this. So, you know, if you were going to guess what's going to happen next, you might guess it right. Some people have guessed like it's going to turn back into one. Some people guess you're going to have like four. Some people say there'll be two super long ones. Like right now, you don't even know what to think. You're just like, I don't know what just happened. I don't know. But cut it up. We'll talk tomorrow. It does basically make like an infinity sign. Look at that. The infinity sign for the Infinity Wars. 6, 7, 8, I think are just pretty self-explanatory. They're asking you, like, if you had a grid and you tried to cover it up with dominoes, different ways can you do it? They say like a domino can cover 2 boxes at a time. So I could cover 2 boxes, 2 boxes, 2 boxes, 2 boxes. Could I grab dominoes and cover every square 2 at a time? Sure. They take you through some domino-based, can you pave different shapes with dominoes? Yes, no, maybe so. Try them. There are some of the domino questions that you think should be no's and they're yeses, and there's some domino questions you think should be yeses and they're no's. Just like you thought you knew what was going to happen to my Mobius strip and you really had no clue what was about to happen there. Some of these do go kind of surprising. So, anybody question about what games you're trying to play? What do you think? Okay. I'm not expecting you to bring the strip back. So what you would do on the homework, you would take your thing home, you would tape it, you'd cut it all up. You could write down maybe a description. I cut it again, I got 18 pieces or whatever happened. But you could just write a note on your homework like, yeah, I did it. But I'm not expecting you to try to bring these strips back in your backpack. try to find a way to take this home without destroying it. You know, somehow, that's a weird piece of paper that won't well fit in your backpack, but, you know, find some way to try to get that home in one piece. We'll go from there.